Hi, in this lesson we're going to focus on cryptography. This is an important and interesting topic. It's really necessary to understand cryptography in order to understand how it is that we can trust the internet to handle our banking transactions and credit card transactions. So let's take a look at this important topic. Let's start with some basic terminology. Cryptography means secret writing. Encryption means converting plain text like the word hello into ciphertext, a word or text we don't understand, like KHOOR. Decryption is the opposite process, taking the ciphertext, turning it back into plain text. So we transform KOR into hello. We're going to be looking at what's called the Symmetric Encryption Model. Encryption and decryption require a key and an algorithm. Symmetric encryption occurs when the same key is used for both encryption and decryption. So this is a picture of the basic model we're going to be looking at. Alice is trying to send a message to Bob. She inputs the word hello and the key for this algorithm into the encrypt algorithm, and out comes the word KHOOR. She sends that to Bob. He inputs the same key into the decrypt algorithm and gets out the word hello. So they've communicated the word hello encrypted. Eve, of course, is the eavesdropper. She can see everything that Alice sends to Bob and vice versa, and she's trying to figure out what they're saying. She's trying to break their encryption. So that's our basic model. We're going to see several examples of it. Let's first start with one of the simplest ciphers, the Caesar cipher, which goes all the way back to 34 BC. In Caesar cipher, the key is a number, small number, such as the number 3. And the key represents the amount by which the alphabet is shifted to create a new alphabet. Let's look at the details of that by looking inside the algorithm used for Caesar cipher. Here's our plain alphabet. It's the letters A through Z. What the Caesar cipher does is it creates a cipher alphabet by shifting the letters of the plain alphabet to the left. So I'm taking the D and I'm shifting it all the way over under the A, as you can see. And notice that the A, B, C wrap around to the right side of the alphabet. This is a shift of 3. Okay, so that's the Caesar cipher. Let's try some encryption. If I want to encrypt the word hello, then I start with the H in the plain alphabet and I substitute it with the letter K from the cipher alphabet, the corresponding letter. Same for the E. The E becomes H, the L becomes O, it becomes O again, and the O becomes R. So hello is transformed into KOR. Decryption goes just the opposite direction. Given the ciphertext, we look up the letters in the cipher alphabet. So the first letter K is substituted with H, and the second letter H is substituted with E. O is substituted with L twice, and R with O to get hello. You can see how simple the Caesar cipher is. I'm going to pause here now and let you try your hand at Caesar cipher.